Now let's talk about VLAN Trunking Protocol, or VTP. VTP is a messaging system, or what I like to call a gossiping protocol, that maintains VLAN configuration consistency throughout the entire network. VTP does this by synchronizing all switches to the latest configuration information. Say, for instance, you want to add a VLAN on a particular switch. You can go and add that VLAN to that switch, and if you've only got, say, 3 or 4 switches, it's not a big problem to go to each one of those switches and add that VLAN. However, what if you've got 50 switches? After a while, if you try to add or configure that same VLAN on each one of those switches, chances are you're going to fat finger one of them somewhere along the way. So therefore, VTP steps in and makes it possible for me to add a VLAN to one switch, and that information is propagated to all of the other switches in that administrative domain. VTP has 3 modes: server mode, client mode, and transparent mode. When a switch is in server mode, you can create, modify, or delete VLANs from that switch. In addition, the VLAN information is synchronized from that switch to other switches in that same VTP domain. The information is also saved in NVRAM. When a switch is in client mode, you cannot create, modify, or delete on that particular switch. However, the client will synchronize with other clients in the same domain, as well as synchronize with other servers in the same domain. The information, however, is not saved in NVRAM. When a switch is in transparent mode, that switch operates almost as if it's an island to itself. There, you can create, modify, or delete VLANs. However, this switch in transparent mode will not synchronize with other switches. It will forward advertisements on to other switches as an intermediate switch. Now, in order for this synchronization to take place, VTP uses what's called revision numbers. Each time a VLAN configuration change is made, the revision number is increased. Say, for instance, I add VLAN 10 here on switch 1. At this point, the revision number at the beginning was 0. However, now I've added this VLAN, which changes the revision number here to 1. We'll say Rev 1. The revision number on switch 2 is still 0. So when these two switches compare notes, switch 2 says I've got revision 0. Switch 1 says I've got revision 1. I have a higher revision number. So therefore, switch 2 says, well, send me your information. So now switch 1 sends its latest update. So now switch 2 is at revision 1. The same thing happens here with switch 3. Switch 3 synchronizes with switch 1 to revision number 1. If on switch 3 I then go and add VLAN 20, this changes the revision number here now to revision number 2, at which point when switch 3 and switch 1 compare notes, switch 1 will see that switch 3 has a higher revision number and will synchronize to switch 3's information, bringing the revision number to 2 on switch 1, and eventually switch 2 will synchronize as well. Extra caution should be taken whenever moving an existing switch from one existing environment into another environment, due to the fact that you may have a higher revision number on the switch that you're bringing into the new network. By default, all switches are in server mode, which means that, say for instance, you deleted all VLANs before you moved that switch over, thinking that you were erasing the configuration, and that switch is already on revision number 42. But the revision number in the existing environment is just at revision number 2, which means that what you've just done is you've erased all the VLANs in the new environment. This is one of the reasons why transparent mode exists. Transparent mode switches would completely ignore any VLAN updates on any of the other switches around it. However, it will pass on or forward advertisements between different clients in the same VTP domain. So keep in mind, VTP is a messaging or gossiping protocol that maintains VLAN configuration consistency throughout an entire administrative domain.